Hello viewers, welcome to Emmanuel Maths Academy. So today we'll be looking at the topic differentiation. Differentiation simply means the change in a variable with respect to another variable. Example, if you are given a variable y expressed as a function of x, you can say that the change in y is given as dy dx, which is equal to f prime of x. In differentiation, there are techniques, or maybe we call it rules of differentiation. And the number one rule is what you call the power rule or the general rule. Let's say under number one, the power rule or general rule. This simply means if you are given a variable y expressed as a function of x to be equal to x prime, then the dy dx, which is equal to what? F prime of x. F prime of x is equal to, now listen, look at what you do here. You use the power to multiply the base, then you subtract the power also by 1. Look at what I mean. We have n times x power n minus 1. This is your dy dx. In fact, this is the most fundamental, the rudiment of what you need to know to be able to solve using subsequent techniques or rules. Now, example, if you are given something like, example, y equal to x power 8. The dy dx here is dy dx here is equal to what? You use this 8 to multiply the base. 8 times x power what? 8 minus 1, which is equal to what? 8x power 7. Another example, if you are given something like y equal to, maybe let's say 2x power what? Maybe power 3. We can even say 2x power minus 3. Then the dy dx is equal to what? 2 multiplied by the power, which is minus 3, times x power minus 3 minus 1. Here now becomes what? 2 times minus 3 will give you minus 6. X minus 3 minus 1 will give you minus 4. This is your dy dx. Let's just solve maybe one more example for you to get a clearer picture. You can also be given something like this, y equal to a fraction this time, maybe x power 1 over 2. Then the dy dx is equal to what? 1 over 2 x 1 over 2 minus 1, which is equal to what? 1 over 2 x power minus 1 over 2. As simple as that. Now, the next technique, or maybe the next rule, is what we call the sum and difference rule. What is sum? Sum simply means the addition of two numbers. And what's the difference? Difference means subtraction. Now, let u and v be differentiable function of x. Then f of x equal to u and v. Remember that u is a function of x. U is a function of x and v is also a function of x. Then the dy dx, which is equal to what? F prime. This prime simply means the differentiation of this. F prime is equal to what? Du dx. Differentiating u with respect to x plus differentiating v also with respect to x. As simple as that. Example. If you are given a function like maybe y equal to x squared plus 2x, you're asked to find the dy dx, derivative of this. You can see we are having an addition here. You can even have a subtraction. It doesn't mean anything. So we will be doing what we did here in the power rule. We'll be taking them one after the other. We'll be using this technique to solve this first x squared, and after use the same technique to solve 2x. Is that clear? Now, dy dx equal to 2x. 2 minus 1 will give you 1. So we have 2x here. Plus 2x. Oh, we have invisible 1 here. Right? Don't worry, let's take it one step at a time. So here you have 2 minus 1. And here we have what? X. An invisible 1 here. Minus what? 1. Which is equal to what? 2x plus 2x raised to power 0. And from the law of indices, any number raised to power 0 is 1, apart from the 0 itself. Now we have 2x plus 2. This is your dy dx. Let's look at another example. If you are given something like y equal to 3x3 minus 2x2 plus maybe let's just say plus 10. You're asked to find the dy dx of this. We have dy dx as what? 3 times 3 raised to power x, 3 minus 1 minus 2 times 2 x 2 minus 1 plus what? 0. Right? If you differentiate 10 with respect to x, you have 0. It's called constant. Whenever you differentiate a constant, you have 0, because you can see that all these are having the variables. You are having x here, But here we can't see any x. But again, look at the explanation here. This particular thing can be expressed in terms of this. Now, aside, let's just look at this. If you have 10, you know 10 is the same thing as 10 times 1, right? The same thing as 10 times 1. Is that correct? Now, from the law of indices, this can be expressed as 10x power 0. It's still the same thing, right? It's still the same thing, right? Because x power 0 will give you 1. And 1 times 10 will still give you 10. Now, from this, to differentiate this, you have to use this 0 to multiply this 10. And also subtract. If you bring this one down, you have what? You have 0 times 10 times x 0 minus 1. 0 times this will give all 0. That's how we got this. But just bear it in mind that anytime you are differentiating a constant, you get 0. As simple as that. This is just like an illustration. Let's continue with our solving. Now, from this, 3 times 3 will give you what? 9. X, 3 minus 1 will give you 2. Minus 2 times 2 will give you 4. X, 2 minus 1 will give you 1. But you know in mathematics, you can't say x power 1. There is invisible 1 here. And this is your dy dx. As simple as that. Thanks for watching.